So first and foremost, I would like to go ahead and I would like to thank everyone for tuning in tonight for our first Nature Program Series evening program of the new year of 2021. Before I turn things over to this evening's presenter, I wanted to first take a moment to thank our Nature Program Series sponsors. Hancock Lumber and Ragged Mountain Equipment for their continued financial support. I also want to put a plug in for a couple of our upcoming programs. Next Thursday, we have, it's been, I think at this point, 9 or 10 years since we last had him, but we have author and naturalist Michael Wojtek from over in the Pioneer Valley in Western Mass, who is going to be presenting on sort of bark and getting to know your trees. Winter tree identification. So, you know, we find that tree identification gets a lot harder when you don't have leaves to look at. So we have that going on next Thursday and a couple of other exciting programs coming up after that. But we are very excited this evening to have the new, and I know you're not new, the new project leader, but I think it was a couple years since we've had Christine Rhines, the former Moose project leader, come and present on the state of the New Hampshire moose population. So we are excited to have Henry Jones, the current Moose project leader, presenting tonight. For those of you that have not joined us for a virtual program before, or if this is your, or if it's been a while, just a reminder that I believe you are all muted on entry, and that's just so we don't pick up background noise. If you do have a question during the program, what I would ask you to do is type it right into the chat box, and I'll be monitoring that. If it's an immediate clarifying question, I might jump in and interrupt Henry to have him clarify. Otherwise, I will hold off and I will ask those questions of Henry at the end of the presentation, at which point you are also welcome to unmute yourself and ask questions directly of him. But with that said, I will hand things over to Henry.
Okay, great. Well, thank you, Nora, and thank you all for, thank you for the opportunity to speak with you all tonight and for tuning in. Yeah, really appreciate it and look forward to talking with you about moose. And I just wanted to start off by saying, you know, what I'm going to speak with you today, it is the, you know, much of the information that I'm going to provide is the culmination of many years of work of many professionals. And here in New Hampshire, that would be the previous moose biologist, Christine Rhines, and then folks at the University of New Hampshire, Dr. Pete Peekins, and a lot of his students. And so, yeah, you know, I didn't come up with a lot of this, you know, it's just I'm the messenger at this point, but there's a lot of tremendous work done on moose out there and a lot of tremendous people that have worked on them that I get to speak with you on some of their findings here today. So a little bit of background on myself is I went to UNH for my undergraduate and my graduate degree, and I worked on a master's project focused on moose here in New Hampshire, and that was in 2014 and 2016, and we'll get into some of that work today as well. So without further hold off, let's progress through. So first, I'm just going to kind of open up with some key moose points, and then we'll get into more detailed information. And so moose, these are just things to keep in mind as we go through the presentation. They're generally a low density species, but shifts in forage shift with forage and can be moderately abundant. So what do I mean by that? You know, generally you're not going to find a lot of moose in an area, but if you find a lot of forage for moose, there may be a moderate amount of them. In New Hampshire, moose abundance was unsustainably high, and density dependent factors catch up. So you know, what we remember for a lot of moose in New Hampshire, that was it's considered a hyper abundance of moose when you look at it across North America and really global moose range. And something was going to catch up with that population here sooner or later. How do we conserve moose in New Hampshire a long time? We'll get to that towards the end, long term. And then we have an ethical question for all of you folks to think about kind of towards the end of the presentation. So first, we're going to start off though with just some background on moose that I think is helpful to keep in mind when thinking about moose and to have perspective on the species. So, and this is true with all wildlife, you know, it's pretty incredible how their adaptations and their physiology that allow them to survive in our natural environments. You know, given we're all sitting in climate controlled buildings on a night like this, and they're all outside doing their natural ways of life. And so it's always neat to step back and think about that, and moose as well. And so moose are a browser, and the Algonquin term for moose is, well, there it is. I don't know how to pronounce it, but it refers to as twig eater. And so as a browser, moose consume woody vegetation. These are twigs and small shoots of trees and shrubs and leaves and those tender shoots in the summer. And so throughout the year, moose will consume 20 to 45 pounds of woody vegetation per day. And that's for an adult moose, a moose that's going to weigh 750 to 100 to 1,000 pounds on the hoof. So all this food they're taking in, all this woody vegetation, that has a 50% digestibility. They can only get nutrients out of half of that. And to sustain, you know, 750, 1,000 pounds off of kind of woody twigs, you know, how do they do that? And so they're a ruminant, and that means they have a 4-chambered stomach, unlike us, so similar to cows. And at the bottom there, you can see that anatomy picture of a moose. And what I'd like to focus on there is that purple part in the center of the moose, and that is the stomach. Much of that stomach is the rumen, and some have described moose as a walking rumen. But you know, that stomach, you know, is a large portion of their organ system, and it's really what allows them to have this kind of ecological niche or lifestyle. So they get up and they eat a lot, you know, browse, take in as much as they can, and then they go and they lay down and they regurgitate that food, masticate it, chew it back down, get more nutrients out of it. And so that is advantageous for a moose in many ways. It's kind of this feed, rest, feed activity pattern. And moose are also a prey species. And so, you know, they're going to feed and try to be aware while they're feeding, but then they go and they rest. And at those times, they also have their senses up for potential predators as well. All right, so next slide. So for moose ecology, optimal moose browse is 4 to 16-year-old regenerating forest. And in New Hampshire, kind of the natural disturbance regimes that caused that would have been insects and disease, wind throw, ice events, and river ice shear. Now that is largely logging, but also some insects and diseases and other natural disturbance regimes at time. And moose move with the food. So, you know, they have long legs, big body, they can cover some ground in a hurry. And it really doesn't seem like a lot, you know, for given their movement on a per increment time. And so, yeah, they move with the food, but the food also moves. And it's been called the shifting mosaic. And so when you think about this optimal browse that's 4 to 16-year-old regenerating forest, you know, so that means that a given forest is only ideal browse for moose for 20 years out of its whole, you know, 100 to 200 year life cycle or more. And so, you know, that shifts in the landscape, and moose are going to shift as well. And so in this picture, if you look like on the lower left where it says shifting mosaic, you might find relatively few moose in that area. But if you were to go up to the area that's been harvested pretty heavily in recent years, you're going to find a lot more moose. A little bit further moose ecology. So I already said, you know, your average adult moose will weigh 750 to 1,200 pounds, and they stand 6 feet tall at the shoulder. So this large body size is advantageous for a number of reasons. One, they can move to that food in most weather conditions. So really restrictive snow for a moose is over 36 inches, and only extreme cold will stress calves. That 6 foot height at shoulder, combined with a long neck and long nose, they can access browse, twigs that are a variety of height. Allows them to access forage when it's a little bit older than some smaller species. Additionally, moose, they do have natural predators. Like I said, those primary predator of moose are wolves, and that large body size gives them a little bit of a competitive advantage to deal with wolf predation. So all these things combined make them, they're a species of the north. And in the lower right, you can see global distribution of moose, or circumpolar distribution of moose. And so we're kind of at the southern edge of that. And so, yeah, so here we are, moose distribution in North America. You can see New Hampshire is at the southern edge of that range. And what limits moose at the southern edge of their range? A lot of people, or sometimes people talk about heat stress in moose. And it's important to be careful about that, because the same things that allow them to shift with their food also allows them to be fairly adaptive with heat. And so if you have good habitat for moose that includes forested swamps and cool seeps, they can tolerate warm temperatures, and they're just going to move to those cooler areas when it's hot. But at the southern edge of their range, it's really a combination of climate and parasites and disease that influence moose. And so you see certain, just overall moose health declines, and you start to see certain diseases pick up, as well as they interact more with other species that carry certain diseases, such as white-tailed deer and brainworm. And so brainworm, or also known as moose sickness, it's a neurological disease caused by the meningeal worm or brainworm. And meningeal worm, or P. tenuis, is carried by white-tailed deer. Over 70 to 80% of white-tailed deer have this worm sitting in the top of their meninges, so between their brain and their skull cap there, and it doesn't cause any clinical disease. And however, it does, when it gets into moose, it does cause clinical disease. It causes, you can see on the right there, next to that moose with antlers on it, those are some of the symptoms of infection with P. tenuis in moose. And this parasite is most common in the eastern part of moose range. It's thought that has something to do with moisture regimes as well. But dosage is critical. So we're going to get to that in the next slide here. So with brainworm, or moose, P. tenuis, how do moose get it? Well, actually, moose and other cervids get P. tenuis by ingesting snails or slugs. So what happens is, P. tenuis gets passed as eggs in deer feces, and those, or actually gets passed as larvae in deer feces, and those larvae hatch. And then if a snail or slug comes along, it gets on those feces, it becomes infected, and then when a moose or other cervid ingests that snail or slug, it then becomes infected. So there's that intermediate host. It's not directly deer to moose, but generally when you see more deer, you see more brainworm in moose. And it's important to note that brainworm is known to cause long-term decline in moose populations to disappearance in localized areas. Another parasite of moose that comes, more common at the southern part of its range is the winter tick. However, I'd just kind of like to clarify right off the bat here a difference between winter tick and brainworm. Brainworm can cause localized disappearance of moose over long time periods. Winter tick will reduce moose numbers, but it hasn't been shown to remove moose from an area. So winter tick, that is it's a different species of tick than you and I typically get on us. So we typically get American dog ticks or black-legged ticks, and the adult female winter tick, which is the second one from the right on the top, that resembles the American dog tick. It's about the same size, coloration pattern is similar, But the life cycle is, the timing is different. People do not typically get winter ticks on them. And actually, winter ticks really don't like bare skin. So it has a 1 year, one host life cycle. The primary host is actually the white-tailed deer, and the winter tick is native to the Northeast US. And so what influences winter tick abundance? It's really this kind of dynamic between moose abundance, weather, and then also the presence of winter tick. And that'll kind of tip the balance either way. And so for moose, more moose equals more winter ticks. It's a classic host parasite relationship there. And then you have the kind of intermediating or additional influence of climate on this relationship. And so short winters are ideal for the winter tick life cycle. A little bit ironic, right? But so short winters will tip the favor in favor of winter ticks, meaning that you'll have more winter ticks in areas with shorter winters than you would in areas with the same number of moose and longer winters. So the winter tick life cycle, and this is kind of important for those previous points that I made to kind of understand why certain things limit winter tick abundance. So May to August, they are eggs in the duff layer. And then in late August, they hatch and ascend the vegetation, and they are larvae on the vegetation questing. And that means they are trying to get on a host. They put out their front legs and are trying to attach to a host. And winter ticks form these clumps. They interlock their rear legs together and form clumps of hundreds and quest. And so when an animal gets, brushes up against one of these clumps, it gets quite a few winter ticks on it at once, or can at least. And so they stay on that vegetation questing until either they get on a host or cold and snow arrive to therefore they're an ectotherm. And so at that point their energy, their mobility becomes very slow. Essentially they become inefficient at life and eventually die. So a critical time is during this questing season. Do they attach to a host? If they don't, before cold and snow sets in, then they die. If they do, then they make it through the winter, and they're probably going to lay eggs and continue the cycle for the next year. And so they stay on that host November through to March, and I believe that's why they're called the winter tick. And they go through a couple of life cycles, or life stages, I should say. And so in March and April, the adult female winter ticks take a blood meal, and then they detach and fall off the moose. And at that point, they bury themselves into the duff layer and lay eggs, and the sequence starts again. So how do ticks impact moose? So moose, similar to deer and a lot of other ungulates, important to remember that usually winter forage quality is low, and that's natural. That happens even on the best range. So in winter, these animals lose weight, so they naturally put on weight in late summer and fall, and then they use up some of that extra fat and muscle over the winter because they have a diet that doesn't provide their daily energy needs. It's lower than what they take in or than what they need to survive per day. And so over the course of winter, moose condition is declining, and then you add on all these winter ticks. And so once those adult winter ticks start attaching and start engorging, they'll itch a little bit. And so moose will start itching, scratching, trying to get these ticks off. That's less time spent feeding, which exacerbates that insufficient diet a little bit. And then, in March and April, all those adult engorged female winter ticks start engorging, and they each take 2 to 3 milliliters of blood. And so when you have 30 to 90,000 plus winter ticks on you, and each adult female, which represent about 25% of the ticks on the moose, 25 to 50% of the ticks on the moose. When each of those takes 2 to 3 milliliters of blood and is a messy feeder, that ends up being a lot of blood removed over a short period of time. And so, yeah, you have, this extreme blood loss, and to replace lost blood, it's not available in the moose's diet. And so they have to catabolize their muscle, metabolize their protein, and then use that to make energy and to make blood. And so you end up with anemia. Essentially they are losing blood at a very high rate. And this can be acute anemia or chronic anemia. Either way, the result can be similar. And that is mortality of calves in March and April, and adults in poor condition. And just when I say acute and a chronic anemia, what I refer to then as acute anemia is like if you have a calf with a whole lot of winter ticks on it, like really high infestation, 45,000 plus, over a 4-week period, it's going to lose so much of its blood that it essentially dies due to shock. It's almost like a person, gets their arm cut off and has massive blood loss. Chronic anemia is more of that when, moose is having blood loss over that 8-week period, and it just can't catch up with that protein deficiency. It eventually runs out of muscle and can't replace the lost blood. So important point is you see calf mortality in March and April. These are 10, 11-month-old calves. And then you see adults in poor condition. Typically, adults survive. Why are moose impacted more than other species? So they have a short evolutionary relationship with winter ticks. Moose came to North America across the Bering Land Bridge, and so they started in the northern part of North America and they moved south. Winter ticks originated with white-tailed deer in the southern part of North America, and they moved north. And it's only been in recent times that they've overlapped. And so moose are stimulus groomers. They don't try to get the ticks off until it itches. At that point, the ticks are digging in. It's too late. Deer are program groomers, so they are always cleaning themselves, always licking their coat, removing the winter ticks. All right, so before we shift into New Hampshire specific information, had a quick pop quiz here. And so what sense does a moose rely on the most for detecting danger? Eyesight. And so this would be, more fun in person, but we'll do what we can, this way. So eyesight, actually they're somewhat nearsighted, and their definition of sight is not considered great. Hearing, you can see those big ears, it's a pretty acute sense for them. Or is it smell? They have that long nose, pretty well developed nostrils, and there's a lot of olfactory cues that are used in the moose life cycle. Well, I guess it can go for a toss-up, but hearing seems to be the kind of the most keen sense that a moose uses. You see in this picture that young bull there in the forefront, his eyes are closed, his nose is down near the ground, but those ears are still up. And I tell you, if you're sneaking in on a moose, they really detect it if you break a twig. And another impressive thing about moose is, given how large they are, they can be silent moving through the woods, which is really impressive. Okay, for New Hampshire information, let's just go through some background terms before I, mention them in discussion here. So a calf is 0 to 1 year old, and calves are born in mid-May. Yearling moose are 1 to 2 years old. Adult moose are 2 years or older. And when we talk about moose productivity, that is the number of calves born per yearling or adult cow moose. How many young are they producing? Winter tick epizootic, and you'll probably just hear me say epizootic. Essentially, this is a year with high winter tick impacts over a large region. And when we talk about high winter tick impacts, we talk about many dead 10 to 11-month-old calves, and then suppressed productivity of yearling and adult cows due to poor condition from high winter tick infestations. So statewide moose abundance in New Hampshire, 1988 was when we first started really kind of our long-term data set on population monitoring, and the population peaked there in the late 1990s at about 7,500. Now we're down 3,000 to 4,000, somewhere closer to 3,000 likely. So you can see it's been substantial decline. And during that period of population expansion, we had, essentially it was moose nirvana, as Chris Rhines would say. We had great habitat. That was when the forest in the Northeast was starting that regrowth, that second growth of forest since post-colonization, or that regrowth of forest post-colonization was coming back. And there started to be widespread forest harvest of those stands, as well as there was large spread outbreak of the spruce budworm in northern New England that causes mortality of balsam fir. So there was a lot of regenerating forest, a lot of really great habitat. There were no predators for moose, and parasites and diseases, relatively new population, it really hadn't caught up. So the limiting factors of moose in New Hampshire. So the map on the right there, the different colors represent different moose abundance. And so we have moose abundance declines from the north to the south. And really in the White Mountains in north is where 2/3 of the population is. And moose abundance there is, 2 or 3 to 4 times that of what it would be in central and southern New Hampshire. And so for the population in northern New Hampshire, where we have these more abundant occurrence of moose, or more frequent, more abundant moose, it is winter ticks. And then for south of the White Mountains, it's habitat, winter ticks, and brainworm. And so let's first go through northern New Hampshire. And so how do we know it's winter ticks? I guess that's always an important question to step back and to think about. And so when that moose population started to stabilize and decline in the early 2000s, Christine Rhines and other moose managers at New Hampshire Fish and Game became pretty concerned, and they decided to team up with the University of New Hampshire and pool resources to understand why. And really the best way to understand what's going on with the wildlife population is to mark individuals, and then to mark enough so you have a representative sample to be able to rest your hat on, provided you can mark animals in a way that does not bias their survival and your results. And so it was decided to radio collar a large number of moose in 2002 to 2005, and then again in 2014 to 2018. And this represents substantial investment, but it was decided, let's put our eggs in this basket, learn as much as we can, and feel confident, and really have good research that gives us results that we can be confident in. And so what did that research show? In 2002 to 2005, winter ticks were the major limiting factor for that population. But, in only 1 of 4 years was there an epizootic, high winter tick impact, and late winter calf mortality was 33%. So not great, but not terrible. And that at that point, population was thought to be stable. 10 years later, 2014 to 2018, 4 out of 5 years had high winter tick impacts, and late winter calf mortality was 70%. So 70% of the calves that survived to March and April would die. So high winter tick impact. And what did this look like in the field? Well, so really high winter tick infestations. Some of the work involved counting winter ticks on moose hides, and those numbers came up with an average of 45,000 winter ticks on recently dead, on calves that died from winter tick infestation. They had low femur marrow fat, and so kind of the rest of these parameters I'm going to talk about really talk about condition. And in all animals, you metabolize your fat in order, and it goes from subcutaneous to the fat around your organs, and then the last fat you metabolize is that in your femur. So if you think about I think it's a ribeye steak, has that circular part of bone in it, and you look in and it's this creamy white. That's how femur is supposed to look, with fat in it. And what you can see there in the center, that's a red jelly. That's femur, that's marrow without any fat in it. Additionally, these calves were losing 23% of their body weight over 2 to 3 months, just massive muscle loss. And when you get to them, they would be, essentially no muscle, skin and bones, really high winter tick impact. New Hampshire Veterinary Diagnostic Lab also did a lot of really great work looking into this, and they did not find other substantial disease. What do we see for adult cows? And so for adult cows, generally a heavy, or for yearling and adult cows, or moose in general, a heavy moose is a healthy moose. And so these parameters on top, the yearling calving rate, adult twinning rate, they all relate directly to moose weight and also directly to physical condition. And these rates have then been applied to understanding where is a moose population in regards to health. And so in 2002 to 2005, there were some yearlings calving, many adults calving, and some twinning. And that was a sign of a moose population that was in good condition. Not great, not poor, just, good. 2014 to 2018, all of those rates declined substantially. And so yearlings were no longer heavy enough to have calves. Adults, fewer were having calves, so it was taking them long to recover from having a calf, and no adults were having twins, essentially. And so that represented a moose population that's in poor physical condition. And generally, not doing well. And so what we see in the field, heavily impacted moose from winter ticks, cows in poor condition. So you'll see a cow with a singleton is the best you could hope for. In some cases, we found compromised neonates, and a neonate is just a newborn calf that's very young. And so these were calves that were born that were non-viable essentially and died at birth. And that's because the cow had to shunt some of the resources that it would have given to that calf to her own self to stay alive. Additionally, you see barren cows. They just don't have calves at all because they need those resources to recover from having a calf in a previous year or just dealing with high winter tick infestation. So generally unhealthy adult cows and yearling cows. However, they do survive. And so adult survival in that study was normal, about 83%. And so what we have going on in northern New Hampshire and western Maine is this winter tick hot zone. And so you can see in between the dotted lines there on the left, the graphic on the left there is this zone. And that's where winter tick measurements on moose throughout the Northeast, that's where winter tick measurements are higher. That's where winter tick impact has been shown to be the highest. And what's occurring there is you have this moderate to high moose abundance is meeting weather that is ideal for winter ticks. And Kyle Ball started some of this, he kind of identified this in his research, and more recently with ongoing research with the University of New Hampshire, Dr. Alexei Soren has worked on it, and he created these maps or figures as well. And so in this moose hot zone, what do we expect? Do we expect that population to decline and disappear? No, we don't. Really the information that we have suggests this population is going to undergo prolonged decline of moose in poor conditions. So that long kind of gradual slope on the left side of this chart. And then at some point that population is going to get to a level where there are few enough moose that they limit winter tick abundance, right? That initial parameter. Remember what affects winter tick abundance? It's the number of moose, and it's also your climate, your winter length. And so once that moose population gets to a level that's less, there's just not enough moose to support a lot of winter ticks on the landscape, you'll see moose condition improve. You'll probably see that moose population increase, but then quickly winter ticks will catch up. You'll get back to moose in poor condition and prolonged decline. South of the White Mountains, what's going on here? And I apologize for the kind of the grainy map there, but for limiting factors, we have habitat, winter ticks, and brainworm. So south of the White Mountains, you get into more of it, well, I should back up and say north of the White Mountains, you have northern hardwood forest and boreal forest, and longer winters, conditions pretty ideal for moose and tree species that generally produce pretty high quality browse. South of the White Mountains, you have less northern hardwood forest, no boreal forest, and you start to get into more oak pine. And so just off the bat, that's a little less nutritious browse for moose. And additionally, you get habitat issues. You start getting into more developed areas, start losing abundance of young forest or really large forest blocks that are suitable for moose. Second thing is, in those pockets where you do still have habitat for moose, you do have moose, but you also have pretty short winters that are really ideal for winter ticks. So you'll probably be seeing winter tick impact at a lower moose density than you would somewhere with a longer winter. Additionally, brainworm has substantial influence on this population. So in most areas south of the White Mountains, you start to get into areas with enough deer that it's been shown to have substantial influence on the long-term trajectory of that moose population. And so that there is higher exposure to brainworm, but there's also divergence on the landscape of deer and moose. And so moose can kind of be in these rugged, large forest blocks, and there'll be relatively few deer there, and then relatively low brainworm incidence. So it's not a one size fits all, but there's a multitude of factors influencing that population. So what can we just do to conserve moose long term in New Hampshire? First thing is, New Hampshire has been, done a great job at this in certain areas in the past, but moose needs large blocks of forest, so we should focus on conserving some of what we have left for large blocks of forest and kind of those great rugged parts of our state, and so try to conserve them, and also if you can conserve them, allow for sustainable forest management, something that will create some woody vegetation at times for moose. Second thing is, hey, we are at the extreme southern edge of Moose Range, and shifts in climate could ultimately impact our moose population long term. So yeah, we really need to pay attention to our impact on the climate, and minimize human contribution to climate change. And then finally, a topic for consideration. And so before I get into this, I should explain the North American model for wildlife conservation is really that wildlife species are managed in trust for the citizenry by state and federal agencies. That means, the state of New Hampshire is managing moose for the people of New Hampshire. And so a topic for consideration: moose in northern New Hampshire are in poor condition due to chronic winter tick parasitism. Human influence on the ecosystem is exacerbating winter tick impact. We've created really great moose habitat. We've removed predators, and then we've influenced weather to be really ideal for winter ticks. Reduced winter tick parasitism and improved moose physical conditions should be realized at lower moose density. So here's the question: do you support healthier moose in northern New Hampshire? Do you support managing for healthier moose in northern New Hampshire through population reduction with hunting? And so, I'm not looking for you to answer that here today or anything like that, but it's something that's going to come up in moose planning here in the future in New Hampshire. And it's something that other states, all states and citizens in northern New England are currently grappling with. And so the research initiated by New Hampshire Fish and Game and UNH in 2002 to 2005 and 2014 to 2019, that blossomed into the largest research effort on moose in the lower contiguous 48 states. And so to date, Vermont came on board and set up a study area with radio marked moose. And Maine developed 2, and now they have an experimental unit, which we'll get to in just a minute. So over that number needs to be updated. Over 900 radio marked moose in the Northeast US. We just have an unprecedented data set and understanding of what's going on. And so Vermont has started acting on the management findings, and in 2020, they issued 55 moose hunting permits in E1 and E2, that's the Northeast Kingdom there, on the premise of managing for healthy moose. The citizens of Vermont said, hey, healthy moose are important to us. And then in 2021, Maine is planning an experimental unit. And so their wildlife management district 8. So that is the new box there with the dotted line down the center. They plan to split that unit in half and reduce moose abundance through hunting and monitor physical condition to see if reducing, if that method is going to prove effective for them to reduce winter tick impacts in that area. And so what is the current management approach in New Hampshire? One, it's outreach. We've learned a tremendous amount, and we currently are fortunate enough to collect some good information on moose. And so it's communicating with the people of New Hampshire and with everyone who's interested, like all of you tuning in tonight, about what's going on with moose and what can we do and what should we do. 2, offer opportunity through conservative harvest while learning. So there's still a hunting season on moose in New Hampshire, and every moose that's harvested, we collect as much information from as we can, and it provides us with an improved understanding of that population. And through this and through other monitoring efforts, we are trying to understand at what moose density winter tick impact is low. And it's a question that varies with each part of the state due to that differing climate and that differing moose abundance. And so it's something that we're working hard to collect more information on. And we're also continuing to work with the University of New Hampshire and their expertise on understanding this impact and innovative ways for monitoring and conserving our moose population. So with that said, do folks have questions?
What is your opinion of hunting for moose control?
Sure. Yeah. So so my opinion, I guess I'll give you my professional opinion, and that is hunting hunting in moderation will not influence. Well, so the current hunting approach will not does not influence our population, and hunting in moderation, I think, will continue to provide opportunity, and it should allow us to have healthier moose sooner than without hunting. So from my professional perspective, there is no reason for us to stop hunting, and that is an opportunity. It is a chance to offer opportunity with this population. And so that's kind of what I'm charged with as a manager, is to, one, ensure the population will be sustained, and we have good information to say that's true, and then 2, to offer opportunity when it's possible. And opportunity for moose, viewing is really important of moose, and I would say that's number 1. And then 2 and 3 would be people just recreating, finding antlers, and then hunting as well. Given human influence on this system, and kind of this, that winter tick influence on moose is pretty morbid. I think that hunting as a tool is suggested.
All right, thank you, Henry. Thank you so much for this presentation. I have a question, and then one that's come in through the chat box. And so again, if folks want to type their questions in there, or you can go ahead and and ask them directly. But just out of curiosity, how does Vermont's moose population compare with New Hampshire's?
Yeah, let me go back a little bit. So Vermont is the Northeast Kingdom there is very similar to New Hampshire's moose population. In fact, moose, Northeast Vermont, Northern New Hampshire, Western Maine, it's all the same moose, is what some people say. And it is. Mm-hmm. We see this with the radio marked moose. Moose from New Hampshire have ended up in Vermont and Maine. And so, yeah, it's similar. Moose abundance could be a little bit different. It could be a little bit lower in Vermont. but generally similar conditions influencing the two populations.
Okay. And then a question that came in through the chat is, and I know when you talk about, 45,000 winter ticks on an individual, but is there a way of cleaning off or removing them from a moose while it's alive?
Yeah, that's a really good question, and it comes up a lot. And so, I need to work on the information on New Hampshire Fish and Game's website about this, but Christine Rhines did a great job addressing this, and other provinces and states have as well, Maine and New Brunswick, and Quebec as well. And so the answer is no. Some people talk about introducing insecticides, which would really be the only other option. And for one, it's not even known if there's an insecticide that's effective. And two, the ecological ramifications of that are not something that is recommended as well.
Okay. And then I have here, it looks like our Tin Mountains research director, Rick Vanderpool, has a question. So Rick, if you want to go ahead and ask Henry your question.
Great. Thanks, Nora. Hi, Henry. Great presentation. Appreciate it. I noticed that the study areas are all in the sort of boreal forest, and whereas supporting a limited moose hunt to improve health may apply there, the current hunt, the current lottery allows for hunting in a lot of other WMUs that are south of that region. I was wondering if those regions, like say in the Lakes region, have been studied equivalently to determine what the appropriate hunting pressure might be to improve health.
Yeah, that's a really great question. We do not have the level of information on moose in central and southern New Hampshire that we do in northern New Hampshire. And so I'm just going to have to say, no, that information has not been collected. But we do collect information on population health and so through weighing moose, and we have a long-term data sets on that. So we have a feel for what is going on, but we do not have the level of information that we do for northern New Hampshire. And that was really decided that, New Hampshire has limited funds, like any agency, and which we all face with natural resources. And northern New Hampshire is our core moose habitat. That's where moose are most likely to persist. Central and southern New Hampshire, given the other influences on moose, it was decided to not influence that. But what New Hampshire takes a very conservative approach with moose hunting on those populations. And so it's generally thought with moose, harvesting 1% or less of that population, you're not going to influence the population. And that's right where New Hampshire is down there, or down in these parts of the state. It's a very conservative approach, given that we don't have the level of information further north.
Thank you. Another question that came in from another researcher we have watching is, do moose populations that have predators such as wolves have the same winter tick episodic events?
Yes. I can't completely answer that, and that gets into so the answer to that question is yes. But what is happening in New Hampshire and Vermont and Maine is unprecedented for winter tick epizootics. So winter tick epizootics occur throughout much of moose range in North America, but they are typically pulsed, short periodic events. They're 1 to 3 years, and then your moose population declines and or your weather shifts, and it's less ideal for winter ticks. What we see here is kind of this sustained high density of moose or moderate density of moose and sustained weather that's ideal for winter ticks. And so more northern climates are those areas that do have wolves, but so they also have winter tick impacts. They also have, currently it's tough to understand where we are density wise compared to them. But in a general sense, they do not have the the really high densities of moose that northern New England saw in the recent past.
Okay, thank you. Another question, this one more of a logistics one. Can you eat, is it safe to eat moose meat from an animal that was infected, heavily infected with?
Yes, yep. No, it is, and that in part it's due to the time of year. So moose, when they are hunted in October or in their best condition of the year, winter tick parasitism, winter ticks are only getting on them at that point. They've had all summer and nutritious browse to recover from winter tick parasitism the previous winter. So yes, it is safe.
Okay. More questions tied with hunting, and this one is, so given that moose are dying without they're dying through winter tick, how long without hunting would it take for the moose tick balance to be reached, and is hunting quickening equilibrium while reducing the suffering of moose?
Can you repeat the second part of that?
So it's asking whether whether the use of hunting is quickening, the point at which we hit that equilibrium.
Yes. So the short answer is yes. Hunting could be used to speed the point of reaching that equilibrium. When are we going to reach that equilibrium, or how long will it take in New Hampshire? I do not know the answer to that question, and that's what we're looking to learn more about and really understand where we are right now. And so really any kind of management approach proposed in New Hampshire would have, we'd have a lot of kind of I guess sideboards in a way, but we'd be looking closely at animal condition, and it would be carefully set such that if animal conditions improves, that population is going to stabilize or then be allowed to increase. And so the answer to that question is hunting. Yes, it could be used to shorten that time to improve moose condition, but at what level of moose abundance is winter tick impact thought to be low? We have some information out there on that right now, but I do not have a hard number right now that I could give you for that.
Mm-hmm. So here's a follow-up question to that, sort of coming at it from another angle, and that is, I don't know if this is known at this point, but approximately what fraction of the population would need to be removed in order sort of to reach that equilibrium? Do you have an idea of what population for, and obviously that'll vary depending on the different regions, but do you guys have, strong ideas as to what those ideal populations are for areas?
Yeah, that's unknown, right? And so I'll just start it at that. It could be northern New Hampshire is getting close to that, or it could be half of what occurs in northern New Hampshire. And for the southern part of the state, it's just hard to say. And so, yeah, we do not know the answer to that. But the way that would be approached is that what you do is you do it incrementally. And so you say, okay, well, right now we know the moose are still not healthy. So reducing the population some, not a lot, you reduce it some, and then, okay, is the population still not healthy? Is it still impacted by winter ticks? Then you move forward from there. So at what level, is the population going to be healthy? I can't speak to that, and it really varies by where you are in the state as well, local factors. But it's something that would be, it's not like there would be drastic changes proposed without a method for understanding where the population is.
And just, there was a question. So just, can you give us a rough idea of what the density is for sort of the Mount Washington Valley breed, what the current moose density?
Sure. Yeah. And so in the White Mountains, it's somewhere, I think it's about somewhere around half a moose per mile squared. Yeah, so it's a 0.31 to 0.45 moose per mile squared. And what we see in the White Mountains, or much of the White Mountain region, is we do see lower winter tick impacts than further north in that north region, that orange area and that blue area. And we do see lower winter tick impact in the White Mountains. And so, you know, a management approach would be, you know, the White Mountains would largely be left alone, or not. I shouldn't say left alone, but it would be not really severe, or I shouldn't say severe, but fairly restricted approach in that area, given that we do have some indicators that with the lower density there, moose are in better condition. They are still impacted by winter ticks, though.
Okay, wonderful. I know we're putting you through your paces here, where we definitely have an interested crowd.
Yeah.
But the last question I have listed in here has to do with road salt. And they know that that's something that moose are attracted to, and whether road salt increases the periodic high densities of moose in the spring and summer, and whether that it might be increasing transmission of winter tick.
Okay, yeah. So road salt, you know, sodium, that is attractive to moose in the late winter, really in the spring and early summer, and then again in the late summer a bit. And so it, you know, collects in these muddy pits, muddy kind of seep areas next to roads, and moose will go there and lick them. It does not influence moose abundance. Yeah, moose may be attracted to some of them, and it may congregate in moose, but when they are congregating there, you know, so these areas, they're also wet, and they tend to have a lot of trees around them. And so winter ticks do not do well in these kind of moist, dense canopy areas. So, you know, that's a really good thought, that those could be winter tick hotspots. With kind of the information that we have about winter ticks and how they do as eggs and how they do as questing larvae, that suggests that these areas are not ideal for the winter tick survival in the off-host life stage. But yeah, that's a really great point, and certainly something that I'll keep, you know, in consideration of. And yeah, thank you for bringing that up.
Right. Thank you. I actually, if you have time, there's one more question that just
Sure. Yeah.
on the chat feature. I told you. And this one I'm going to read off just so that I get it correct. So the calving data that was shown in your presentation from the 330 moose that were collared, is there a plan or funding to collar more moose to collect data on their population changes?
So like all the calves that survived from the first round so I guess, you know, my interpretation of the question is there funding to monitor the calves or to offspring from the first round of moose that were radio marked? And the answer to that would be no. You know, the current effort to radio mark moose is over. It went for 4 years, and really monitoring calves went for 5 years. It's pretty expensive to do that. You actually need a helicopter and a professional moose mugging crew to catch moose in the most efficient way. So that's pretty expensive. And what we learned about the population, we felt is sound to apply to all moose. And so no, and some of those moose, though, that were included in that 2014 to 2018 research, some of those moose were offspring of an adult cow. So if we had a collared cow and knew she had a calf, it may be desired the capture crew may have gone over and marked that cow and watched its survival as well. So.
Okay, great. Thank you so much. And I think that's the end of the questions that we have. And once again, Henry, thank you so much for this presentation. It's just been very informative and helpful, and we appreciate your time so much.
Sure. Yeah. Thank you. I really appreciate the engaged audience, and I should have included this in the slides in the last slide there. But feel free to reach out to me with questions, comments, anytime. I'm interested to hear your feedback and your input. If you have a pen and paper ready, I can write down my email. We're currently dealing with staffing shifts with COVID, and so calling can be logistically challenged. But if you have a pen and paper out, I'll tell you my email, and feel free to reach out. And Nora, feel free to provide this.
Wonderful. I was going to say that I can, if folks connect with us, we're also happy to put you in touch with Henry.
Yep. And so my email is, it's all lowercase. It's henry.jones@wildlife.nh.gov. And so, so thank you all for tuning in tonight. I really appreciate your engagement and your interest and enthusiasm for moose. I should have said this during the presentation, but we're lucky to have moose, and I think we're all focused on doing what we can to have moose in the future, and to do our best to conserve the resource. So thank you for your interest, and please reach out with questions.